Well, thanks everybody for coming. And as you may have seen somewhere, this session is going to be about Android open source repositories. And if you can learn at least one new thing on this session, that would be a huge success. I feel a bit pressed because Nico Kort is here, which is the top Android open source maintainer in the world, so don't be too harsh. Anyway, so I'm currently working at Snap doing Android and Kotlin. I'm also managing the Kotlin Weekly. If you don't know it, it's a mailing list that sends every Sunday news about the Kotlin world. So follow it on Twitter and subscribe if you haven't done that already. And this is my Twitter, and from here you can reach my Mastodon handle as well. So yeah, just to provide a bit of context, in general, as an engineer and, well, personally, I try always to share what I learn and, well, trying to get some feedback and, well, teach other people and learn from them. That brought me at some point to the Google Expert program, the Google Developer Expert. Well, I was talking sometimes and giving workshops, writing content, you name it. And open source is part of this story. Generally, you, well, can either contribute to other repositories. You might have some ideas that, well, you want to make them implement this as an SDK or library, and I think it follows this approach of sharing what you know and getting some feedback and, well, interact with the community. Disclaimer, that was mostly before the family. Now I have other duties after 6 o'clock, so my contribution levels yeah, are not the same as before. And this also contains a little bit of a personal journey. Like always, you need to see what suits in your life, what doesn't suit, what's good for you, what you believe in, and some things might apply, some things might not. But in general, again, if you can take like 1 or 2 learnings from here, I think that would be great. For me, there was a first time contributing or creating open source code. It was in 2012. At that time, I was living in Barcelona, in Spain. And, well, while checking WhatsApp, I realized that WhatsApp, well, it already had a few vulnerabilities reported. You could change the status of any other mobile phone by making a HTTP, and I say HTTP, not HTTPS request to an endpoint. The traffic was also not encrypted. And they were actually storing the conversations from your entire WhatsApp in the external memory in a file that was encrypted using the same encryption token for everybody. Not a token that used your phone number, not a token that was using your phone ID, just the same token to encrypt every conversation. So I developed an exploit that was basically Java library that was finding this file on the SD card, was sending it, well, decrypting it, taking the text, the database inside, and sending it per email on the background thread. If you are doing Android, you basically needed 2 permissions for this. Back in 2012, the network permission and the external read or read external permission. So I published it as exploits. Then at some point, I got a letter from some agency in the US saying that they were going to sue the ass out of me. I started seeking like some legal advice, but then luckily GitHub removed the repository that I had here. So they somehow forgot about it. It was my first experience in the open source world. And yeah, maybe it was different from publishing your library. But anyway, that brought me into the open source ecosystem. Why sharing? There is a concept in the investing world, which is the blue and the red ocean companies, which I found it quite interesting, and I think it applies to open source. So red ocean is an ocean that has a lot of competition, and well, you could see that there are many sharks, and there is one person in a boat, and they only can eat this person, so they're going to compete against each other, and probably this is not going to bring a lot of joy into your life. Whereas the blue ocean, it's, well, a guy sitting on a boat, fishing some fish, and he is probably having a brighter life because, well, there are more fish than people on a boat. Of course, this is from a purely theoretical standpoint. Global warming, like depletion of oceans, but let's not going to start with that. So in a red ocean strategy, you're competing, the market doesn't grow, you need to beat the competition by making prices a little bit lower, and that's typically what telecommunication companies are doing. So Deutsche Telekom or Vodafone, they can't really grow that much because they have in Germany like 80 million clients. They sell subscriptions to DSL and cable and internet, and what they do is decrease prices. And if you check the stock value of Vodafone, British Telecom, see that they follow the same pattern. Whereas in a blue ocean, companies can create new concepts, competition, or they don't need to compete because they are creating this new demand, which is typically tech companies, Google, Apple, Microsoft, which, again, if you check the stock evolution for those companies, looks quite different than telecommunication companies. And I think it's similar to the open source world. Of course, everything with a grain of salt. You cannot publish 10 different network clients on Android because, well, there is limited space for them. But the space for ideas is wider, right? You can publish new libraries, doing things that you believe they can be right, and the world is better after that library than before. So I started at some point publishing more libraries. The first two non-exploit libraries that I published were Android Stack Blur. This was back in 2013 after Apple announced this blurring concept in one of the Apple versions, and that was bringing it to Android. It was applying the same concept using Java back in time, or the NDK using C++, which was faster, and also render script, which according to the benchmarks was even faster. So I don't know if my C++ implementation was SIT or render script was even better. And this library was also relying on more open source because I was using an algorithm from a guy called Mario Klingelmann from Munich, which is very much into visual computing and open vision and stuff, and well, his algorithm was open source, so I took it, ported to Java, and then bam. And back in time, Tinder started becoming popular, so I created another library that essentially was creating those sweepable cards that you can add to your app and have this sort of a card interview that you can like, dislike, and include some pictures and a stack and some animations. Later on, I was working at Google, working on some of the Maps libraries, so namely the Google Places SDK, the Maps SDK utility library, which, if you don't know, provides functionality for clustering or, well, certain things that are not added on the standard Maps SDK, or Android Maps Compose. Of course, on these ones, I had a bit more of pressure because you had a couple of millions more users than on my personal ones. And I also learned a lot about automation and good practices that you need to follow, which I'll be talking about them now. Well, first and less interesting topic for developers, nonetheless very relevant, because based on this, you can essentially fact up your open source library from the beginning, is which license you need to follow. Long story short, Apache 2.0, but I think those three ones are the most relevant ones that you see generally in the open source world. And basically, GPL is the hacker library that contributes or proposes a lot of copyleft and encourages the contribution back to the open source community. It also has a small clausule that says that derivative works need to be distributed under GPL, which, of course, if you want to get this integrated into commercial software, might not be especially liked by lawyers at your company. Then MIT and Apache 2.0 are very similar. They are permissive, so you can use those libraries for commercial usage, modify, distribute code, etc. Requires to have the original copyright notice in the copies of the software. So this is, well, generally on your app, you need to have at some point these open source licenses and include, well, a list of the libraries that you're using. The main difference with Apache 2.0 is that Apache provides some certain level of protection for patents. So if there is any patent that you are having or you're expecting to have or you would like to have on your code, Apache could be a bit more apt for that. So just as a summary, GPL is the hacker free, as in free beer license that could prevent a little bit derivative and commercial works. And MIT are generally very permissive. You can do most of the things you want with them, fork them, integrate them in your project. They do not have a lot of copyleft protection, could be good or bad. But one thing is that doesn't really encourage the contributions back to the open source community. And Apache 2.0 has a couple of terms that can eventually help you to support any patent that you might have on your app. Now, contribution guidelines. How do we contribute to software? How do we establish what should be done and we should operate? I think in general, a good example are the contribution guidelines from Google, which are also forked from this IndieWeb Code of Conduct that you can also check. It's a large one. I think we could probably be talking for a long time about them, but I think the most important ones is they can be summarized as don't be an asshole. So generally be kind, assume that everybody is trying the best, so ask instead of taking assumptions. Don't be an idiot, so no harassment or threatening people or stuff. So be a nice human being and have some respectful behavior. Not saying that Linus Torvald is not following that approach, but if you go to this repository, there are some rants from Linus. I think somebody even made some sentimental analysis about the rants that he was having on the mailing list from Linux. And let's say that maybe this guy was not following those contribution guidelines. Even at some point in some conferences, he recognized that, maybe he's from a different generation or background. Then guidelines should include how to find issues that already exist, how to get started with a project, if you need any special build, setup, submitting pull requests, things that you should be observing, having a clear README file, etc. If you don't know about this, GitHub provides you can add some default markdown files to GitHub, such as the code of conduct markdown, contributing, the licensing, of course, the README file, which is going to be rendered at the bottom of your repository, security guidelines, and on the right side of your GitHub repository, they're going to be preloaded, so you can click them and they will automatically redirect you into those specific pages, so they're more accessible for your contributors and community. Yeah, I think a good example I like is TensorFlow. TensorFlow is a huge repository, contains a lot of, has a lot of contributions. I think it's one of the top, at some point, I think it was even the top 2 or 3. And it's, in my opinion, contains a nice example of everything. They have a getting started guideline with how to get it installed and compile it for different architectures. If you're developing Android, generally you're doing different things because you don't need to pre-compile artifacts and distribute them. But you could have things like how to get my library initialized. Do I need to pass a token? How do I call this constructor? Which basic options do I have? It's really better than borrowing them after a lot of documentation. It's easily accessible. I can take it and get it running in a couple of minutes. You can also link from here the contribution guidelines. It doesn't need to be the complete one, but just some basic one. So if you want to contribute, here are those guidelines. Here you can see the code of conduct. Here you can see the issues that we have open, and this is our Stack Overflow track. From here you can see all the questions that have been asked, etc., etc., etc. They provide also a build status. So on TensorFlow, you can see the latest builds for Linux or Android or Windows, how they're working, if they're building or passing. Again, on Android, this is something that you might not need, but providing a build status or the status with the latest test or linking to the builds could be a good practice. And further resources. Again, it's going to depend on your project. I like that from here they're linking to tutorials or the Twitter account or the YouTube, because most of the people are going to be checking the README first, and it's also reasonable also to provide this snapshot of information at first. Forward, as Android developers, I guess maybe you had this problem at some point, your application is crashing, you don't know why, and it only happens when you're using ProWare or 8. It's nice to give the ProWare setup that you needed for your application and have it also in an obvious place. Maybe linking it from the README file would not be a bad initial place. So, well, people can avoid this problem, which eventually is going to happen. When it comes to documentation, we have a few options. Considering using the code as a documentation is a good practice, since, well, people are going to be reading our code, and again, it's not always nice to take assumptions. In the Android world, typically we will be using KDoc, which is not a tool itself, it's the language or model that we use to add code, uses Javadoc syntax, but it's not a tool to generate HTML pages. For that, we would be using Doka, which generates the documentation based on the KDoc, and well, you add it as a plugin to your project. They also support multi-module projects, so if you have submodules, you can set it up to, well, avoid the samples or include some of them, or, well, I think it's fairly customizable. Or, of course, Javadoc, if for any reason your project just needs to rely on Java and Javadoc. Its documentation as a website is also a nice consideration. You have places like javadoc.io where you can upload your documentation automatically, so the HTML pages that are generated are automatically uploaded here, and, well, people can find them easily. Or even including a custom website that is going to have your documentation. This is what Dagger is famously doing. They also provide this nice example about what is Dagger and dependency injection, or we have a coffee machine and this composed of different parts. So it's something that, based on your project, could be worth considering, or maybe not. Code style. You probably have been working at some companies with, when you're starting, they send you an codestyle.xml file, and then they say that your company should be following this style because for any reason it's better than the standard one. I don't think in 2024, this is a space where we need to innovate too much or be very creative. Everybody's using Android Studio or IntelliJ. Android Studio is based on IntelliJ, so the guidelines, I think, are having well tested, they're spread, and most of the people are using them. So you probably don't need a reason to come up with your own set of guidelines, and just relying on the ones from Android is going to be a good idea. Then automating dependencies. One of the problems that we could have in a project is that dependencies tend to get outdated, and, well, you need to find time to add them and keep the project updated. And for that, we have a few solutions. I think right now the two widely used ones are Renovate Both and Dependabot. They're a little bit different. So Renovate Both is a GitHub app where you need to install on your repository, and Dependabot, it's, well, I think right now it's integrated directly with GitHub, so you can just go to the GitHub settings, add Dependabot, and it's going to add a dependabot.yml file that contains the setup. And, well, the setup is fairly simple. You can define for both Dependabot and Renovate Both the interval that you want to have, whether it's weekly, the maximum amount of pull requests that you want, the commit message, how do you want to prefix it. You can package them. So sometimes you might want to have, I don't know, exclude some packages, include another ones. It's flexible in this regard. Renovate Both, I think, is more flexible, allows things like auto-merge, batch updates, and Dependabot is a little bit more simple. In my opinion, both of them do a good job. Yeah, semantic release and semantic versioning. I think when we are releasing, it's, well, one of the spaces where the manual interaction can fuck up a release, because, I don't know, for any reason you are messing up when you're doing it. I think this, well, this is an action / package that takes care automatically of your release process based on how you're prefixing your commits and merging them. It also creates automatically the release notes, publishes the package, so it really takes care of everything. You don't need to do anything. This might be a little bit small, but in order to use it by default, you need to use the semantic versioning prefixes, so things like build or docs or fit. And the standard setup is going to release based on the how you're naming the commits. You can change this on the configuration. By default, any fix is going to release a fix release. Fits or releases, so the minor one. If you include breaking changes, it's going to create a major release. So it's nice because you decouple from the emotions of the release and you let semantic versioning do the job. A couple of votes more that could be interesting. Inclusive language is a GitHub application that you can install. If you're adding any non-inclusive commit, it's going to warn you. You have also you can tag things like error or warning. So if you're using, for example, blacklist, you should consider an alternative, etc. Then Prosbot, it's like Grammarly, but for commits. So same thing. If you are adding, having some typos, it's going to notify you at the commit level. So it's also useful to keep a very lean list of commits. Detect, do we have any detect maintainer or owner over here? Yeah. It's basically, it's going to keep your code clean and linted and making sure that you're following a very nice style. So you should probably be adding this also to your repository. Consider tags. I think tags are they're very useful for categorizing commits, but labels can also be used to trigger a specific action. So we could have labels for nice first issue for newcomers or bugs or things that we need to explore. But we can also have tags that trigger UI tests. For example, UI tests are expensive. Maybe we don't want to release them on every single commit. Then we could work through an action that adds labels, and then those labels are triggering different things. I think are heavily underused. It's a way of setting up commits on the specific way that you want. In general, code reviews should run the automated linting and should run the automated testing. It's probably worth an entire session whether UI tests are part of this or not. So that's something that you need to see how they fit in your process. But as a rule of thumb, testing, no code review gets merged without being tested first. And by doing creating GitHub actions in this .github folder, you can have run a lot of them, right? So for example, measuring the entire test coverage, you can deploy the new documentation, you can run the unit test, the instrumentation test, and if this is merged in the main branch, for example, you just trigger the release. Exactly, so you can have something like this. All the checks need to pass, and if they don't pass, then they block the pull request, and you make sure that, well, the points that you believe should be fulfilled, they are all successful before the code, before you actually click the merge button. Coco, it's a very nice tool. You should be using it on your project. So it has a few configuration options, but basically you can get the total test coverage that you have for your project. You can aim for a minimum one. So if the test coverage is under 50 or 60%, nothing gets merged. You can see the files that have, how much the files have changed the test coverage, how much test coverage the individual file has. It's a tool that is very flexible options to set it up. But if you're not using it, it's very easy to set up basically a few lines on your Gradle file and on your GitHub action, and you have them already in your repository. SonarQube, it's also a static tool that is going to check potential bugs that you have, vulnerabilities, if there is any security hotspots, any code smell. I think they can coexist with some other tools. SonarQube specifically, it has a community version and then a paid version. So maybe, for open source, the community one is probably enough. For corporate ones, I think the paid tool also includes like some maintenance and stuff. So it's good considering. And well, Fastlane. Not sure how many of you have used Fastlane. I think It's mostly used for apps. But well, in open source, in the open source world, you might want to cover also apps, right? Because maybe you have a sample app that gets deployed into the Play Store, and you want to take screenshots and run the test. So maybe it's another option to consider. I think it basically helps with the app deployment, taking the screenshots based on your test, does the code signing on iOS, which on iOS is a pain in the ass, and takes care of the distribution as well. Code owners. If you haven't used this before, by creating a code owners file, and now it's integrated on GitHub, so you just can go to GitHub and from there directly create this file. It can specify who takes care of what. So you create a similar file to this, where the handle of specific developers can get assigned to specific folders, and well, basically they get assigned automatically, and they need to review the code before it gets merged. For release management, consider semantic release. Again, you can follow the manual process. I think semantic release in this sense is really good, because takes care of the release for you, and you don't need to have emotional discussions about what things get in and what things get out. Well, for that, you will need to have the Maven plugin, right, which you add to your Android repository. You specify the group ID, the artifact versioning, and then this gets published into Maven. Yeah, using release management, you end up with something like this, which is nice. It takes care of the release notes, so everything that is a bug fix gets documented here based on the commit names. It reflects the issue when this was solved. It reflects the pull request where this was solved, reflects the commit, reflects the issue where this was reported, and whether this is closed or not, and also the breaking changes. So it's very nice for generating everything automatically. And well, basically, you need to have this release RC file, which is also very nice because allows you to run specific commands. For example, in your open source code, probably on the README file, you have like, this is my last version is 0.9.2. So you could create a custom script that after release is going to go into the build Gradle file, is going to search for this version regular expression, and is going to replace it with a new version that is coming on the release. So you don't even need to update your documentation on your README. This is done automatically. The more things we do automatically in general, the better. Now, Compose. Let's going to talk a bit about code. I guess as Android developers, you probably do Kotlin and Compose from time to time. I wanted to use AI for a couple of things in these slides. One of them was generating graphs. So I asked ChatGPT, create an image of an Android developer loving Compose. And starts telling me a lot of bullshit. There is no image coming in. So on the second one, I say, you don't display any image. Keeps talking without displaying the image, and at the end, you're not showing any image. So keeps talking, and then I get this image from here. I love Jetpack Compose. Is this an Android developer loving Jetpack Compose? I don't think so. So do's and don'ts. I think, one thing that we should do is consider the value. Here we're going to be talking about Compose API guidelines. There is another thing for general Compose usage and good practices. In this case is how do we expose our composables? Because people are going to be using them in other projects. So the interface needs to, well, follow those guidelines. First one is that, well, we should see the value that each component is adding and the problem that is solving. In general, they should solve a single problem. In this case, we have a button that is handling the on-click, and then it's also clicking the check and on-check chain. So in this case, probably we should have two components and two different actions. Like you see here, it's probably better to have, and this is what Compose is doing as an API, has a single button with an on-click event, and then it has a toggle button with an on-check change. As a good practice, you should see the listeners that you're passing, because I don't think you should have a lot of listeners. So a code smell, it's a composable that suddenly has many that could even be overlapping with each other. Yeah. Yeah, so when creating components, you should provide various layers of single-purpose building blocks, right? So this is also what Compose is doing. We have a text row, checkbox, a checkbox row, which is a higher level that is combining them. So this is a good practice. Then what we should not be doing is doing components that don't have a distinct UI. So creating a padding component that is specifying the padding on components. This is something that well, you see from time to time in Stack Overflow. I don't know if ChatGPT has any responsibility here. Should not be happening. So instead, we have things like modifiers, right, when you can specify the padding, and that's a best practice to follow. It's a bit of functionality can be applied to any composable, but alters the hierarchy of composable. It has to be of components, since a modifier cannot change the hierarchy, a component can't. So what we could have is the animated visibility, which is going to change the hierarchy instead of having modifiers. We should consider basic for components that are bare bones. This is also a practice that you see in the standard compose. They have the basic text field or basic text or basic checkbox. The moment they start getting more specific and have some decorations, you just can remove the basic prefix. Yeah, you should also avoid, maybe related to the previous one, company names, and I guess we've all been at those companies where things start being like company name, class name and stuff, especially talking about open source code, right? We don't want to insert our, I don't know, library name button or anything. So that we need to abstract from here, and in general, just do it specifically for the use case and project-specific need. If your library is based on Compose Foundation, you should also depend on Foundation and not on Material or Material 3 APIs. Then, yeah, we should prefer multiple components over style classes, because then it's going to be harder to decouple them. If composable internally is being styled, then, well, it's hard to decouple it, right? We have this button, and then we need like to restyle it if we want to customize it. So instead, we should have something like, we have this login button that has this specific style, and then the standard button or the primary button or secondary button that are more aseptic and abstract and are not being styled by default. Yeah, we should prefer explicit inputs versus implicit dependencies. So, for instance, we should not have, in this case, this local button border that is externally defined and then added to the composable. Instead, what we should have is the border that contains a default one and that can be explicitly asked and modified anytime. Modifiers. So, well, modifiers is our way to change the UI appearance of components. So every component should have a modifier parameter. It should be the first optional parameter. I think now you get a link warning if you add it as the second one. It should have a no operation default modifier. So if you don't specify anything, the standard modifier is going to kick in and provide a styling. There should be only one modifier type in the parameter list, not having something like modifier animation and modifier UI. We have a single modifier, and yeah, it's applied first as the modifier. You know that the order of the compose appliers can modify the final result. The modifier goes always first. Now, some Kotlin tips. I'm going to rust over this one. I thought it could be like an entire session just talking about it, so I'll just give some general tips. So, generally, we should prefer functions over classes. If we are adding any Kotlin function, name arguments and defaults should be there. Otherwise, we're going to have a lot of breaking changes also, because imagine people cannot specify name arguments, so they need to specify the entire list of parameters. Every new addition is going to break the builds of everybody. We should avoid Boolean parameters. Instead, if we are having a Boolean parameter, probably we should consider an enum or a seal class instead of the Boolean, because we can reflect values on a more linguistic way. So things like this should be added or this should not be added. Sometimes just adding a true or a false, especially if you're not naming them, can be confusing. And extension functions should be used wisely, not generally everywhere. Something that I think it can be a little bit, you can see conflicting opinions here, is whether using seal classes for exception management or not. I think there has been a lot of literature and discussion about this. It's nice to have result seal classes because they're going to return the exception of the result. You see a bunch of articles even from people from JetBrains that are advocating for this, but then you see a lot of JetBrains libraries that are not using result classes. So yeah, again, take things as they suit you, but this is something nice to consider. Seal classes instead of raw and pure exceptions flying through your code. That was, yeah. Okay, yeah, when you're, this should have been before, but anyway, you should define themes globally that you can pass to your app as you're using the Compose API guidelines instead of having like every component individually theme and stylize. Now, backwards compatibility. Now, remember that you are exposing your interface to others. So this is something that every developer would like to see, like the latest Java version, a Java version that doesn't even exist because it's so advanced and you just want to use that one, latest Min SDK. But the reality is that this is going to force people that are using your code. So generally, you need to keep the version as reasonably low as possible because you are now having an influence on the code of others. Again, this doesn't mean that you need to be on, I don't know, Java 1.8. If it doesn't suit you, maybe you can increase to 11, see the APIs that are not working, save with the Min Android SDKs, but you need to be wary of this when you're, you just cannot increase and release because your sample app is working. Consider also the explicit API mode on Kotlin. This is a mode that was added in Kotlin 1.4 and basically forces you to be explicit with the visibility of your API. So you need to define if something is going to be public or private. You cannot just let it undefined because it's going to throw you an either warning or error depending on whether you're using the strict mode or the warning mode. But this is useful. Otherwise, as a library developer, all your code is going to be visible, and that's something that you might not want to have. By the way, here you can, if you search for this skip explicit API modes, you can see when it was proposed and how it was started. It was the KIP 45. So, some summary. Yeah, generally, probably you want to go with Apache 2.0. Be wary of the contribution guidelines, having a legible README file. Think about the documentation, whether you want to have it in code, as a website, automatically deployed to Java.ai. Code styling, follow the Android Studio or IntelliJ guidelines, automate as much as you can, do as little as you should manually. Automate things, especially on the code reviews, using GitHub Actions. Consider code owners to assign responsibilities, publish automatically if you can, follow Compose API guidelines and Kotlin API guidelines, be wary of the backwards compatibility, and last but not least, no silver bullets. Some of those things might be helpful, some of them might not, and your project have circumstances that other projects might not have. Now, a disclaimer, no AI was used to prepare the slides except the previous one that I used. And actually, I wanted to create here another image of a developer fighting against the AI. So I ask also, generate an image of a human killing the AI. So again, it tells me a lot of things, but doesn't give me any image. So I say, there is no image. The ChatGPT apologizes and gives me an image of a human killing the AI. Is this a human killing the AI? I don't think so. Are we close to artificial general intelligence? I don't think so either. So thanks everybody for coming. You've been a fantastic public. If you have any question and I happen to know the answer to that question, which doesn't happen very frequently, I would be super happy to help. And I have this QR code here. If you have 3-4 minutes to give me some feedback about the presentation, I would highly appreciate it. I can use that later to see what you folks like, what you don't like, what makes sense, what doesn't make any sense, and I can improve on upcoming ones. So thank you very much. I think we have 1, 2, 3 minutes for questions. No, okay, well, thank you.